a real tough shape. I know. It's asking a lot to remind you of what a triangle looks like. But one thing I can ask you is this. What is the sum of the interior angles in a triangle? 180 degrees, right? Does that ever change? Doesn't change. Doesn't change whatever type of triangle you have. You always have, it's always 180 degrees in total, right, for all your inside angles. Now, when you start thinking about it and you start looking at all the different shapes, you remember how, first of all, let me ask you this. You know what a polygon is? Yeah, you know what a polygon is? Remember what a polygon is? The shape, okay. What does the Greek word poly stand for? Remember that? Multiple, many, and gon is sides. So it's many sided. So when we start talking about what are called polygons, we're going to look at all the different types. 4 sides, 5, 6, 7, and so on and so on. But they all have different names. Now, what this is doing is showing a more specific style polygon. These are actually being drawn out as what are called regular polygons. Remember what those are? A regular polygon has all sides congruent and all angles. So the smart board, when I draw the polygon and stuff like that, please put your feet down and sit flat. Thank you. When I hit these buttons on the smart board, it's going to draw what are called regular. So it doesn't change any of that up. It's always going to look like those. But remember, it doesn't have to. It could just be a polygon with 5 sides. Okay? It could just be anything. It could look like that, and that's still a 5-sided figure. When you have 5 sides, remember what that's called? Pentagon. 6. 7. There's a couple names. There's a septagon, and the other one is called a heptagon. What about 8? 9. Nonagon. 10. Decagon. 11. It's actually an onsagon. I am lying. It's called an 11gon. A 12-sided one is a dodecagon. And then after that, they're just called however many sides there are. 13gon, 15gon, 27gon, and so on and so on. So when you see these names of things, and I know you've all seen these before, if I say, hey, we have an octagon, you have to know how many sides there are. Now, what do you call a 4-sided one? What's the generic name for a 4-sided? No. Quadrilateral. How many triangles can you put in a quadrilateral? Which means how many degrees are inside a quadrilateral? 360. So what I'm getting at here, when you have 4 sides, I'm going to use this terminology a lot where it says n equals 4. That means number of sides. Right? You'll see. So if I say n-gon, that means if I say there's a 17-gon, that means there's 17 sides. That's what the n stands for. Right? So if I have 4 sides, I can fit 2 triangles into it, which means you get it 2 times 180, which gives you 360 degrees total. Okay? If you have 5 sides, how many triangles can you draw into it? 3 of them. Okay. So if you have less triangles, you get 3 triangles. And what is that, 540, I believe? When you have 6 sides, how many triangles can you get in there? 4. There are 4 triangles. And so on and so on. So what's happening here is that you actually, by the time you start extrapolating your data. You can come up with a generic rule for the number of sides to how many degrees they're going to be on the inside of a figure. Basically, all it winds up being is if you take the number of sides, in this case 7, 1, 2, we have 1, 2, 3, 4, 5 triangles there. I had 6, I had 4 triangles. I had 5, I had 3 triangles. I had 4, I had 2 triangles. So what am I doing each time for many sides? Subtracting 2. So what we're doing is we're getting what's called the sum of the interior angles in a polygon. Always equals the number of sides minus 2 times 180. Always. Okay. Which means if I ask you to find the sum of a 35 gon, what would you do? Okay. Take 35 minus 2 and you multiply it by 180. And like I said, with this style, with the parentheses and all that, you can quite literally type it in your calculator like that with the parentheses, and it's going to work just fine. And that's the whole point of writing it out. So you're hard pressed to screw up. Right? Don't get me wrong, you'll probably screw up something, but it's more difficult the more information you have there. It also works going backwards. Okay? It also works going backwards. For example, if I give you the number of degrees there are in something, you can figure out the number of sides. Reason being is, have you guys ever seen? Oops, you ever seen this before? What does that mean? Distance equals rate times time, right? Now, do you agree that there are 3 variables here? Now, what you can do with this is, let's say I wanted to get rate by itself. What would you do? Rate times time. So what do you do? Divide. So you would divide it. So distance divided by time is your rate. What you're doing here, what I'm showing you here, is something we call a literal equation. When you have something that's what's called a literal equation, you're basically just solving for a specific variable in a formula. Kind of the same idea as when I'm looking at this. If I wanted to figure out, if I know the sum of the interior, if I wanted to get the number of sides by itself, what would you do first? Yeah, you would divide by 180. Because what happens here is if you know what the sum of the interior is, if you divide it by 180, you get the sum of the interior divided by 180 equals n minus 2. So what do you do? How do you get rid of the 2? You add it over. So it's a really nice thing to be able to know that you can work backwards. To get this. You'll see this a lot. Sometimes people like using that generic formula, some people just like solving it out for x on its own. So you can take the sum of the interior divided by 180. And work the other way. Let me show you an example. Find the number of sides if each inside angle is 140. This is for regular problem. Find the number of sides if each interior angle measures 140. Number of sides, each interior is 140. Well, if the inside is 140, what's the outside? 40. Remember, 360 divided by the number of sides equals the exterior angle. Okay, insides and outsides are always supplementary. Which means you do this. 360 divided by what is 40? Well, do you guys remember a whole little thing about ratios? What is a ratio? Oh yeah, the maximum ratio. Okay. Thanks. A fraction, yeah. Ratios are just fractions that are set equal to each other when we start working with these things. Do I change anything if I do that? Put it over 1, does it change anything? No. The reason why you can do stuff like this is because of this. Do you guys agree that this is true? Yeah. Does anything change if I do this? Is that true? Yeah, all I do is change the diagonal. Okay. I flip them. Does that change? As long as I take what's called a proportion, two ratios that are equal to each other, as long as I do the same thing to both of them, we'll always get a true statement. So the idea that just flipping these is why it works. 360 divided by, that's touch on the sides here. There's an N. And that N stands for the number of sides. It's a nice shortcut to remember. It is always, always, always easier to work with the outside and work your way in. So how many sides does that have? None. Exactly. Exactly. Figure out how many sides these two have. Take a second. One of them has an interior of 175.2. The other one has an exterior of 45. Take a minute to figure out how many sides there are. Please. Otherwise, I could say just do a bunch of trig problems. Yeah. You guys are in trig now, right?
Yeah, we're like in the middle. We finished chapter 4.
Oh, so you're in the work problem stuff now.
Yeah. No, we did work problems.
Have you done the airplane barrier problems yet?
Yeah.
Yeah. Well, you always want to take it and draw it, so you know which one to use. Even though they're giving you an interior angle, is it easier with interior angles or outside angles? Which one is less matter? Outside. I wouldn't draw the whole thing, but remember what I was saying is if I draw just the three sides, that's the easiest thing to do. What's up, buddy?
Caleb.
Peace out.
Thank you.
The easiest thing to do with these things
No, okay, that's all.
is no matter what, you agree that somewhere along the lines you're going to have three sides, right? If the inside is 175.2, what does that leave you for the outside? 4.8, right. Now, if each outside angle is 4.8, 360 divided by your outside angle tells you how many sides you have. It tells you how many sides there are. What do you get? 75. So it is a 75 gun. So there's 75 sides there. What's that? That tells you how many, because it's asking you how many sides does it have if each interior is 175.2. All right. Now the next one, it tells you that you have an outside of 45. Again, somewhere along the lines, you'll have three sides put together. If the outside angle is 45, well, the number of sides will be 360 divided by 45, and you get 3. It's a matter of, if they give you outside angles to start with, your life is easy. If they give you the inside, you just got to find the outside. There are many other ways of doing this stuff, guys. I just try to always stick with, always work on the outside because it's easy. You know what I mean? Okay. Find the measure of an interior and an exterior angle if it's 100 gon. Sorry, I'm trying to rewrite this. What's the measure? This is 100. It's a regular 100 gon. What is each interior and each exterior measure? Well, which one's going to be easier to find? The outside. Because how many degrees are in the outside? Outside. 360. Yeah, because when you go around, no matter what, every time you go around something, you always go full circle. So if you've got 100 angles, well, 360 divided by 100 is how much? 3.6, which means each outside angle is 3.6, which makes each inside angle. Oh, wow. Yeah. And that's how it works. Now, not like you're going to ever go out and make 100 gon, because that's just kind of goofy. But we'll probably do a pentagon, a 5-sided one. That's a 20th of the way there. Sorry, that's a great job. Let's do this. What about the rest of this? Do those, please. Let's keep standing in your way. It's annoying. All right. Do those for tonight. We'll get into the polygon stuff tomorrow. Like I said, we'll put everything together. You guys will put it all together Wednesday. We'll get back together on Thursday and finish all this out.